Okay, more inverse functions. Step 1, replace f of x with y. Easy enough. Step 2, solve for x. So we have y minus 2. Well, that's just really good. Y minus 2 equals square root of 3 plus 5x. Okay, how do we unlock these terms in here? We square both sides. Y minus 2 squared equals 3 plus 5x. Okay, then we move that 3 over. Y minus 2 squared equals, well, minus 3 equals 5x. And then x is equal to that side divided by 5. So x equals y minus 2 squared minus 3 over 5. And then finally, our inverse function is not complete until we replace x and y with each other after we have solved. So we have x minus 2 squared minus 3 over 5. And that is our inverse function. For those of you required to prove this by plugging in the inverse function into the original or vice versa, whichever is easier, let's go ahead and do that. So our original function is 2 plus c. F of x equals 2 plus root 3 plus 5x. So to prove this, let's plug our inverse into that. So we have 2 plus square root of 3 plus 5, and we replace x with the inverse function. So this looks lovely. Okay. And we simplify this down to equal x. So at some point this should equal x. So let's get to our algebra. If we look here in the side of the square root, these 5's, once I distribute that in, those are just going to go away. So we're left with 2 plus square root 3 plus x minus 2 squared minus 3. Oh, would you look at that? These 3's go away. 3 minus 3 is 0. And we're left with 2 plus square root of x minus 2 squared. Well, we got a square root squared, so that just cancels that out. 2 plus x minus 2. As you can see, the square root and the square cancel each other, and then these are simply redundant, and we're left with x. So congratulations, you have proved it and found the inverse.